Today's going to be a little bit different. We're talking about using integer chips, and we may or may not have gotten to that in class. I'm not sure how far we're going to get today exactly. But what I wanted to do basically was just to go through this sheet with you that you have in your hands, and it's basically just a practice sheet. So it's not quite the notes, it's just a normal homework assignment, only we may have not gone over it. So I wanted to make a video sort of going over the sheet with you so that you would be prepared to do that. I think that's the best way to talk about these, is just to go through examples so that you can see how to use these. I'm going to assume when you get to class tomorrow that you're going to know how to use integer chips, and you may have a couple questions about them, but in general you'll know how they work. This first video that I'm going to show you just overviews how to use the chips before we go into that sheet. If we talked about this in class, feel free to skip over this part and skip to the part where I'm going over the next sheet. That would be fine. If we didn't go over this, you definitely need to watch this part of the video, because you're going to be pretty confused if you don't. You're going to get to class and not know what to do, and then the homework sheet, you may have it right because I'm going over it, but it's going to show when you get to class that you really don't know. So I'm going to go ahead and hit play here.
If you add integers, how can you predict if the sum will be positive or negative? For example, 3 plus negative 5. In this lesson, you will learn to add integers by using integer chips. Let's review. Integers can be modeled with integer chips. Yellow chips represent positive numbers, and red chips represent negative numbers. A zero pair is made when opposite quantities have a sum of 0. Here we have the opposites positive 1 and negative 1. You can think of the opposites as canceling each other out. 1 and negative 1 are a zero pair. A common misunderstanding is to think that more chips always represents a larger value. In the example below, we have 4 red negative chips and 3 yellow positive chips. We might think that negative 4 is greater than positive 3 because there are more red chips. However, we must remember that as we move to the right on the number line, the numbers increase. Since 3 is to the right of 4, we know that negative 4 is less than 3. Let's look at when we add numbers with the same sign. We have 4 plus 2, 4 positive chips and 2 positive chips. Together, we have 6 positive chips. If you add 2 positive numbers, the sum will always be positive. This makes sense because you only have positive chips. Now let's add 2 negative numbers, negative 3 plus negative 2. We have 3 negative chips and 2 negative chips. Together, we have 5 negative chips. If you add 2 negative numbers, the sum will always be negative. Again, this makes sense because you're just adding more negative chips. What happens when the signs are different? Like 4 plus negative 2. We have 4 positive chips and 2 negative chips. When we combine them, we see that we have 2 zero pairs and a remaining value of positive 2. So 4 plus negative 2 equals 2. Let's look at another example, negative 5 plus 4. We have 5 negative chips and 4 positive chips. When we combine them, we have 4 zero pairs and 1 negative chip left. Negative 5 plus 4 equals negative 1. Did you see a pattern when we added numbers with opposite signs? After you make
And we're going to talk about that pattern later. So I'm just going to memorize this. That's sort of what we're going to be doing later this week after we've worked with the chips for a while. So let's switch to this camera if I can find it here. Here it is. All right. Blow that up. So just to make sure you understand this idea of a zero pair, just that this would be a negative one. This is a positive one. And a zero pair is sort of like this. If you had a, say you have a hole, and that hole is 1 foot deep. Because it's going down, we could represent that as a negative 1, or this. Well then, above the hole, you have a pile of dirt, and that pile of dirt should be I mean, spread out obviously, but it should be about 1 foot of dirt. That would be represented as a positive one. If you take this positive 1 foot and put it into the hole, what's going to happen? You take that. It's going to fill in the hole. The hole will be gone, and you'll be back at this line here, which is 0 before you dug the hole to begin with. A 0 pair is when you take a negative one and a positive one and put them together, and that makes 0. They cancel out. It's like owing someone $1 and then paying back $1. Now you don't owe, you owe them nothing, so that's what, when they said 0 pair, that's what they were talking about. So let's go ahead and look at this sheet here. I'll try to zoom in so you can see a little better. So a helium atom had 2 protons and 2 electrons, and you can see their model, 2 positives, 2 negatives. And basically what's going to happen is you're going to cancel out the 0 pairs. 1 positive, 1 negative together makes a 0 pair. So in words, we are left with 0, because both 0 pairs canceled out. There were 2 0 pairs that we crossed out there. Let's do another one. Treasure map said to take 10 steps north and 8 steps south. So I'm going to use 2 different colors so you can see that. So the first thing we're going to do is north, and I know north would be up. So but we're going to do it this way just because it's going to be hard to fit it in. So let's do 10 steps north. We're going to go to the right for north. 1, 2, 3, 4, 5, 6, 8, 9, 10. And then, so we take the 10 steps this way, and then we're going to take 10 steps back, and basically we want to see how much movement we made. Or sorry, 8 steps back. 1, 2, 3, 4, 5, 6, 8. And this right here is kind of like saying you went positive 1, then back negative 1, which makes a 0 pair, so we would cross them out. And what are we left with? You went 2 steps north. So we went 10 steps north, 8 steps south. In reality, that means we went 2 steps north because these all canceled out. And there are 1, 2, 3, 4, 5, I think a total of 8 0 pairs. Jen earned $6 working in the garden, and she spent $5 on a toy. So she earned 1, 2, 3, 4, 5, $6 working in the garden. And then usually we use red if we're talking about spending. I don't have a red Sharpie. I have this color though, so we're going to talk about her spending 5. Now she spent 5. So if she earned 1 and spent this one, those cancel out. That's a 0 pair. Another 0, another. And then we're left with, well, she has $1 left. And there are 1, 2, 3, 4, 5 0 pairs. For some of you, this is going to seem very basic because you've done these before. It is important that we learn to think this way because it's not enough anymore to just memorize the rules. We have to know why they work. So if you've been taught the rules before for this and you say, I already know how to do this, it's also important you know how the models and how the rules work. It's also not uncommon on classroom tests and things like that to see these. So make sure that you're familiar with what the chips look like and the models look like. All right, so we're not going to go through every example. Let's do one more though. The elevator started on the 8th floor. So instead of starting at 0 where we normally start, we're starting at the 8th floor. So that's sort of our line where we're starting. Then it goes up 5. So 1, 2, 3, 4, 5. Sorry, I'm marking over the other problem. goes up 5 and down 2. So I'm right here now. I'm going to go down 2. These cancel out, they're 0 pairs. In reality, we went up 3. And there were 2 0 pairs. So we've gone through 4 examples. Do 2 more on your own from these. If you have questions about them, bring them to me, but you can pick the 2. I'm not going to pick them for you, so pick 2 and do 2 more on your own. Now, looks like we can see through that, so I'm going to get a fresh sheet of paper that you can't see markings through, and this is the other side of that sheet. And we're going to use actual integer chips so you can see me using them, but if you want to draw them on your paper, what you're going to do is shade it in, and that would be a -1. Leave it open as a +1. So that's what they did here. So if we look at this example, well, let's just get that example. We'll go to number 2. So we have 4 positives plus 6 negatives. So a +4, and I do like to circle our terms, +6. So let's go ahead and model that. 1, 2, 3, 4. Even though I know all of you can do 4 plus 6, you learned that a long time ago. It's good practice using the chips. And then we're going to do 6 more positives. And you can draw these just by leaving them open. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. If I have 4 positives plus 6 more positives, that equals 10 positives. Make sure that you have the chips drawn on your paper too, and not just the answer 10. I know that everyone doing this can do 4 plus 6 and know it's 10. This is the important part. Let's do number 13. So 13 says we start with 4 negatives. So I'm going to pull out 4 negatives here. 1, 2, 3, 4. And then we're going to add 2 more negatives. So let's get 2 more negatives. So if we have 4 negatives, and then we add 2 more negatives, I'm filling them in because they're negatives. Well, now we have, let's count them, 1, 2, 3, 4, 5, 6. We have 6 negatives. Let's do another example. So this is where it gets important to pay attention. On this one, we have start with 7 positives. 3, 4, 5, 6, 7. I'm going to go ahead and count them out. 1, 2, 3, 4, 7 positives. And we're going to add to that 6 negatives. 1, 2, 3, 4, 5, 6. And then I'll go ahead and count them out. Now remember, when we put 0 with a number, it doesn't change the number. Let me just get rid of that. It doesn't change the number. So there's this, but everything else is 0. That's a 0 pair. That's a 0 pair. We're just going to get rid of all these 0 pairs. And what are we left with? We're left with a +1. So 7 plus -6 is +1. Number 10. We start with 3 negatives. I'm not going to draw them from this point forward. I'll let you do that. So there's 3 negatives. Then we're going to add to that 8 positives. And it looks like we have, this is 0, so 0 when I add it doesn't change the number, so we're going to get rid of that 0. Going to get rid of that 0. And then what's left? 1, 2, 3, 4, 5, and they're all positive, so it equals +5. Do not forget to draw the chips there. Right. Let's skip to number 16. Please do 12 and 14 on your own. I think that shouldn't be too bad after doing the ones we just did. We're going to do 16 together, though. We have a +4. So 4 positives. And then we have a -8. The reason I circle them is because it's good to get in the habit of seeing that if there's a sign in front, that means it's negative, and to know that those two things are attached.